Hey all, today we're going to continue our review for the SOL, and we are going to focus today on graphing, how we can graph lines, find information out about lines, and use the line or curve of best fit to solve some problems. Again, we're going to be working with using Desmos to assist us with these. So you'll need Desmos open to try some of the problems that I do. So the first things first, if you ever need to graph a line, we can simply just copy the equation of that line or even a quadratic function, which we'll talk about in the next lesson. You can always just graph that thing into Desmos. And if you type in the line, it should give you a little symbol like this. It'll tell you what color the line will be. You can always change your color if you really want to using this little gear to edit it. You can zoom in and out. You can move around. Hopefully you know all these things. And then if you do zoom in, but you want to get back to the basic view, you can always press that home button. So if you start zooming, you're going to see a house appear right there where I circled it. And you can always press that to send you back to this screen. Um, if you haven't zoomed or anything, you won't see the little house button. So that will only appear when you zoom. So those are the basics. Hopefully something you're really used to because we've been using Desmos all year. And one thing we've done this year was to find the slopes of lines, and we used some formulas. We did rise over run. We said slope was subtracting the y's divided by subtracting the x's if you had two coordinates. And then I think we've also done that using Desmos, and I'll bring up again how we can do that. If you know 2 points on a line, you know the coordinates, you can always plug them into a table. You get a table by pressing this plus button up here and then selecting the table option. There'll be like a little chart. In fact, I can actually show that. So I can press the plus button here and then you can hit table and you can enter anything in here, coordinates. You can enter a table if we're given one. And then you can use this equation. This is what we use for the line of best fit, which we'll talk about a little bit later. But what that equation is going to do is it's going to graph the line that goes through those points, and then it's going to give you the slope. And of course, we typically report our answers in fractions, so you could always put negative -0.5 into the calculator and press the little fraction button to get -1/2. It's also going to give you the intercept, the place where it crosses the y-axis, which we would be able to see anyways. And so this is something that you are going to want to commit to memory. And you're always going to want to make sure that you start fresh every time you do a problem, because when you put the little ones by the X's and Y's, it's going to connect to the ones in our table. And so if you've got multiple tables in Desmos, these numbers will change and Y1, X1 will not give you what you're looking for. So I always recommend starting with a fresh, clean Desmos, delete everything out from a previous problem, and then you won't have that issue. We can also graph lines and find the slope by hand by counting how far up we go. So we went up 5, to the right 2. So the slope here is 5/2. If that's something you forget, you can always find the coordinates of these 2 points. So the coordinate of this point is 0, 2. Sorry, 0, 2. Coordinate of this point is -2, -3. And we can actually put those into Desmos. So I'll go to that table I was starting, 0, 2, -2, -3. So it should look like the points that we had here. And I can actually do this y1 squiggly mx1 plus b. And it will give me a slope. M equals 2.5. And so I want that as a fraction. So I could put 2.5 in there and hit that little fraction button over here and get 5/2. which is the same thing I got by counting. So you find a way, whichever way you like best, to find slope. You can do some counting. You can use what we did at the beginning of the year. Slope means you subtract the y's, divide by subtracting the x's, or you can plug some coordinates into a table, use this y1 squiggly mx1 plus b, and the calculator will tell you the slope. So here we're going to do a practice where we plug some things into a table and then use that to answer the problem. So we've talked about direct and inverse variation, and so one thing to note is that with direct variation, that means that when x goes up, y goes up. So when the x number gets bigger from one point to another, the y number gets bigger. When x goes down, y goes down. They go the same way. Inverse, when x goes up, y goes down. So that means when I go from one point to the next, if if the x value is increasing, then the y value will be decreasing. If the x value is decreasing, the y value will increase. They go opposite, they go inverse. So actually, if I look at this table and I go from top to bottom from 1 to 20, my x values are going down. When I look at my y values from top to bottom, my x values are also going down. And I'm going to go back, and hopefully you said, Mr. Pickard, you're crazy. My x values were going up. Sorry if I confused you. 1 to 20 means my x values are getting bigger. I'm sorry. 10 to 0.5 means my y values are going down. And so that means this is an inverse variation. So it's either going to be B or D. And what we need to do is just go ahead and put this table into Desmos, which I've done here. Again, you get a table by pressing the plus and then table. If you can't see all the points on the table, there's a magnifying glass over here. It says zoom fit. If you hover over it, you just click that and it'll zoom it in. You can see all your points. You can see that as my X values get bigger, my points go down. And so I have two equations that I can choose from, either negative 2.5x plus 12.5 or 10 equals xy. So I'm just going to graph both of those and see which one fits. It looks like the red one fits. It goes through all my points. And so that means that's my answer. You don't have to know what kind of line this is. This is not something we've gone and talked about this year. However, you can graph it and you can see that it goes through the points. And so that must be the answer. Here is a bit of a review. I thought it was worth it. We've talked about direct variation again this year. It has this form, y equals kx. And we were given y values and x values, and we were able to find k. And so here we're given a point, and we can find its y value and its x value. Its x value is 2, and its y value is 3. And so we can use that to find k. We can plug 3 in for y and 2 in for k. We can divide both sides by 2 to figure out that k is 3 over 2. Then we go back in and we plug k into our original. And what we want to do here is we want to graph 2 points. And so since x is an even number here and I have this divided by 2, I'm going to choose even numbers. I'm going to pick x values. So I'm going to plug in 4 for x, and I'm going to plug in 6 for x. And what's nice is we can actually use the calculator for this. This is not something I planned on using today, but we can do it anyways. So I'm going to go to my calculator here, clear everything out, and I'm going to type in y equals 3 over 2 x. There's our line. Let me go back and change this to B, A. I'm just going to do the right side of my equation because I'm going to plug x values in and it's going to tell me what y is. So this is kind of like using a slider. So a slider for B. So I said I wanted to make x 4. And so when X is 4, Y is 6. So I plugged in 4. That tells me Y is 6. There's a point on my direct variation. I can change this to anything. So I can change it to 5. That gives me a decimal here. I don't want that. I'm going to change it to 6. When X is 6, I changed X to B. When X is 6, then Y is 9. So X is 6. That's going to the right. Y is 9. I could plot that point. Direct variation. And then actually, if I go back and I type back in what I originally started with, even though I didn't want it at that point, this equation, that line should look similar to what is being formed here. And it does. It goes up to the right. And that's what this does. The other way we could do this is we could actually look and see, well, I can click points on here and see if I can find one that works. So we said 4, 6, that's that point. We could just pick it off of this graph instead of plugging it in. 0, 0 would work. 2, 3 is our original point. We can keep going, but if you didn't want to do the slider, actually one of the easier things might be to just graph this line and find points on it and then go copy them to this page. So we've already sort of talked about this part, and these files are on Canvas if you want to look at them while you're doing the video, if you want to go back to them to review them. Uh, we didn't really change anything in here, but this is just a reminder here that if you want to create a table, you press the plus and choose table, and then you would enter your information. We have these two special equations, this Y1, this is for the line of best fit. We've also talked about the quadratic curve of best fit. This changes a little bit. These are two things that you should memorize because you can use these for the test. And what these things are going to do is they're going to graph a line or a curve that's closest to the table of points that you put into Desmos. And a reminder that if you don't see the table, there's a little magnifying glass that will show up and it'll zoom it in. Once it zooms in, that little magnifying glass goes away. Another reminder that that house will take you back to the normal view. So these two equations can help you find the equations of lines. It can help you find slope like we did earlier. Intercept, you can write an equation using that. And so let's try one here. I put the table in here from this problem. Even though it's not in a table, it gives you X and Y and X and Y and X and Y. So you should type them in that order. Put all my X's in the order I saw them. Put all my Y's in the order I saw them. You need to make sure they match up from the parentheses. They tell us this is a curve of best fit problem. So that means we want to type this special equation in. Again, remember that this X and that Y should both have a 1 on them so that they can coordinate with the ones we put down here. It will graph a curve. If I can't see these data points, I'm just going to click the zoom fit and you can see that that curve goes right through those points. And it gives me the values for A, B, and C. So A is 1.7, B is 2.9, and C is negative 5.2. That's going to tell you what equation you should write. So I didn't really have to do anything by hand, didn't have to work anything out on my own. I put this stuff into Desmos. I have to make sure that I remember this equation. The best way to remember is to write it down a whole bunch of times. So if you're thinking you can't remember this, well, I'm here to tell you that you can. You just write it down a bunch of times, practice it before you get to the test, and you'll be able to remember it. One thing you could do right at the beginning of the test, when it's time to start, you can write these things down onto the scratch paper you get, and then you don't have to remember them from that point on. You can just use them when you need them. I have another one here. This one is calling for a line of best fit. So I plug the data in here about buses and the months they're used and the distance they're driven. It's a line of best fit, so I'm using my Y1 squiggly MX1 plus B. It's going to give me a slope and an intercept down here, M and B. Just a reminder from a long time ago when we did this, it gives you extra information, but we don't need it. That's for a different class. So what we're asked is how many miles could we expect a bus that's used for 40 months to drive? And so this months used is an X, distance driven is a Y. And so what I'm going to do is I'm going to take my slope and my intercept and I'm going to type a function in here. I'm just going to use the exact numbers they give me. I'm not going to do the squiggly or the X1 anymore because I want this to actually graph a function. And then I'm going to ask the calculator, hey, when X is 40, so I do F of 40, what is Y? And here we have an estimate for the number of miles driven, 91,426. And that's as close as we get to it. So that's our answer. Reminder that if you have any questions from this lesson, this review, we are covering a lot of information in one short lesson. So please do ask if you're having trouble with calculator functions, please do ask. There are 10 problems. If you get stuck and don't know how to do one, it's appropriate to ask so that you can practice these skills, practice the tool of using Desmos to answer these problems. There are 10 of them, one per page. Take your time on these. And again, if you need help, feel free to ask.